Okay, let's finish the 10-3. So yesterday we had the matrix to solve for A, B, C, D, right? And we set it up with two equations. And what we did was we took the matrix 1, 4, 1, a negative 1, negative 3, set it to 1, 0. And then we also took the 1, 4, negative 1, negative 3, and set it to 0, 1. We could actually, instead of doing this separately, did I start the recording? Okay, we could actually do this in one shot instead. So what that means is I could take this matrix and set it up as 1, 4, negative 1, negative 3, 1, 0, 0, 1. And if I was to now go through all the process to turn the left side using Gauss-Jordan elimination, we could turn the left side into the identity. But as we're doing that, we're doing math on the right side too. And what happens is the right side ends up becoming the inverse. Okay, so solving the left side to put it into the identity will make the right side the inverse. And I'm not going to mess with doing that right now. So here's the matrix. They call this a doubly augmented matrix. So we have A on the left side, the identity on the right. And then again, as we go through and perform Gauss-Jordan elimination, we will turn A into the inverse, the identity, and then the identity turns into the inverse. So I guess we will do this. Okay, I want the left side to be a 1 here and a 0 here. Can we do that easily? How can I turn that negative 1 into a 0? Row 1 plus row 2. Agreed? Okay, so if I take row 1 and add it to row 2, I get this new matrix. Do I have the identity on the left side? No, I do have row echelon form. I don't have reduced row echelon form. To get reduced row echelon form, I need to get rid of that 4. How can I get rid of that 4? Multiply what by negative 4? So if I take row 2, multiply it by negative 4, and add it to row 1, okay? So I take negative 4 times row 2, add it to row 1, and that's what it gives me. Do I now have the identity on the left side? Yes. Okay. Okay. So here we took row 1 and row 2, we added these together, right? 0, 1, 1, 1. To get a 0 here. Now, to get a 0 here, this is now row 2. This is not. This is row 2. I'm going to take negative 4 times row 2. So here's negative 4. Negative 4 times 0. Negative 4 times 1. Negative 4. I'm going to get good at multiplying negative 4 and 1. Okay, so those are all negative 4s, right? Now, if I combine, this red represents negative 4 row 2s. 1 plus 0 is 1. 4 and negative 4. 1 and negative 4. 0 and negative 4. Okay. Yes. Yes. Okay. So recall that this right here was my beginning matrix. This here is the identity. When I got done, what is this? This is A inverse. Which means if I took matrix A, this 2 by 2, and multiplied it by A inverse, what do I get? Identity. But if this is true, it must also be true that A inverse times A must also equal the identity. Okay?
How can you tell if something is the inverse?
You multiply them together, see if you get the identity,
Oh, well, how could he just look at that and tell it was the inverse?
because I just did the math.
We weren't multiplying together though. Oh, like.
We took this matrix to here, to here. Because we turned this left side into the identity, and everything we did to the left side, we did to the right side, we turned the identity into the inverse. Yes.
I feel like what we're doing is easy, but it's hard to tell what to do.
Everything we do in this class has different levels of ease.
If you go back, I couldn't help but notice the fact that you added some extra.
I know, me too. I was looking at, really thought that I
Do what? Oh, I did add these. Because in the notes, they didn't specify exactly what we're doing. So I added, use elementary row operations to turn the left side into the identity matrix. Yes, I added those words to the slide. This is the left side. Is that the identity? This is still the left side. Is this the identity?
Yes.
We turn to the left side into the identity.
Like, is it always just gonna give you the?
If there's an inverse, then yes. We'll worry about that in a little bit. Hold on to those questions. I don't want those questions on this recording. Okay, so here's what we did. We took, this is the matrix we started with. We had A and the identity. We did our matrix voodoo. The left became the identity, the right became A inverse. Huh? And second period. And y'all can watch second periods also. I post them both.
I'm just now learning about your.
Yeah.
Okay, but it doesn't
You
show
know, I
that.
also don't look to see whenever he posts videos.
Okay, let's move up. We don't want to.
I wouldn't want to hear.
Okay, y'all have an assignment. You send. We're not even going to finish the lesson. I'm not going to show you how to do these problems. I'll just. Okay. So to find an inverse matrix, we write the n by 2n matrix. Why is it n by 2n? Because we have taken a square matrix and put the identity with it. That made it, the width was twice the number of rows. If possible, row reduce A to I using elementary row operations on the entire matrix. Moving along. The result's going to give us the identity on the left, the inverse on the right. Check your work to see if the original A and your calculated A inverse do in fact give the identity. And always check both ways, A times A inverse and A inverse times A. Use Gauss-Jordan elimination to find the inverse of a matrix works well. For matrices of order 3 by 3 or greater. Yeah, we're not going to do anything bigger than a 3 by 3. For a 2 by 2 matrix, however, many people prefer to use a formula. There's actually a formula to find the inverse of a 2 by 2 matrix. So here it is. It's a simple formula. So if I have a matrix, the matrix is A, B, C, D. That's a 2 by 2 matrix, correct? The inverse is equal to 1 over A times D minus B times C. Here's what they did. A times D is the down diagonal. B times C is the up diagonal. We added the downs, subtracted the ups. And this concept is going to be important in 10-4. Okay. We took the product of the down diagonal and subtracted the product of the up diagonal. A, D minus B, C is the determinant. We don't go into a whole lot of detail about determinants in this section. We hit it heavy in 10-4. Okay, the down diagonals minus the up diagonals is called the determinant. Now, we found the determinant. We took 1 over the determinant. And we multiplied that by the matrix. But look, it doesn't say A, B, C, D anymore. Here's what happened. We swapped the DNA. We changed signs on B and C. We swapped the DNA. We changed signs on B and C. That's the formula for finding the determinant. I'm sorry, for finding the inverse of a 2x2 matrix. Let's find the determinant of matrix A. We find the inverse, but to find the inverse, we have to find the determinant first. So for letter A, let's start by calculating the determinant. And the determinant again is AD minus BC. All right. What is A? 3. D is 2. Minus B.
Is -1,
C.
-2.
You good with this?
Yeah.
So that's 6 minus 3. 6 minus 2. 6 minus 2
4.
is 4. Okay. What? A, B, C, D. Now let's do the formula. The formula says 1 over 1 over 4 times. Swap your DNA. So the 2 goes here and down here goes 3. And then change the signs on these guys. Okay. Multiply everything by 1/4. So 2 times 1/4. 1/2. 1 times 1/4. 1/4. 2 times 1/4. 3 times 1/4. Okay. That's the inverse. I'm not going to mess with checking it. You can do that if you would like. But if I took matrix A and multiplied it by this answer, what will I get? Identity. Okay. Part B. First thing I want to do is the determinant. For Devaya, that's A, that's B, that's C, and that's D. The determinant is AD minus BC. A lot of times I'm going to say down minus up. Okay. AD is the down diagonal. BC is the up diagonal. Down minus up. Okay. 3 times 2 minus.
-1 times
Okay. 3 times 2 minus -1 times -6. 6 minus 6 is?
0.
Now let's apply the formula. The formula for calculating the inverse is 1 over,
0.
oh, time out.
Can't divide by 0.
Can't do that.
So is it impossible?
Okay.
Does not exist?
No inverse exists. If the determinant is 0, there's no inverse. Yes.
Good question. If B one of them was positive, would you just add together instead of subtracting?
We would be subtracting a negative number. Yes. Yes. But I write it down exactly as it is, you know, parentheses, number, minus, parentheses, number, you see what I'm saying? But yes, effectively, you will be adding. Yeah. Pay attention to your signs because they will get you. Mhm. Questions on this concept? Okay. So here it is. They've worked it out. So part A, the determinant was not 0. They worked it out. Next slide. That's exactly what we got. 1/2, 1/4, 1/2, 3/4. Part B, determinant is 0. Because the determinant is 0, B is not invertible. So we stop. Next slide. You know that the system of linear equations can have exactly one solution, infinitely many solutions, or no solution. If the coefficient matrix A of a square system is invertible, then the system does have a unique solution, which is defined as follows. If A is an invertible matrix, then the system of linear equations represented by AX equals B has a unique solution by X equals A inverse B. Okay, what did they just do? I've got AX equals B. X represents my variable. How would you get X by itself? We can't divide. Multiply by the inverse. So I'm going to take A inverse times AX equals, and remember, we're talking about matrices here. Order is important, right? Matrix A times B is not the same as matrix B times A, right? Okay, so because I wrote A inverse on the left side, I'm going to write A inverse on the left side over here. What is A inverse times A? It's the identity. It's 1. That's where that came from. Okay? Here's a matrix. We're going to solve by using an inverse. So the first thing I need to do is take the system of equations and write it down as a matrix equation. So coefficients. 1, 1, 1. That's it. I just want the coefficient matrix right now. This is my A that I'm building right now, okay? I'm building my A. Next row. And I didn't give myself enough space again.
0.075.
For the record, I always put zeros in front of my decimals, but I'm not this time because of space.
0.095.
Y'all good with that? Last row.
1, 0, -2.
Okay. What is my X matrix?
10,000.
No,
No, isn't it just X, Y, Z?
X, Y, Z. These are my
Oh
variables.
my God.
X, Y, Z equals B. What is B?
10,000.
There you go.
730. 0.
Okay. So all I've done is I've taken the coefficients, wrote them down. I wrote my variables down. I wrote my answers down. Remember, if I was to multiply this, it's row by column. If I took row 1 times column 1, I would have 1x plus 1y plus 1z. Second row times that, I only have one column. Second row times that column, 0.06x plus 0.075y plus 0.095z. So all I'm going to do is I'll multiply this together. I would get what I started with. Okay. So this is my X and this is my B. I need to find the inverse of this guy. Okay. I am not going to spend the time right now finding that inverse. I'm going to go to the next slide and tell you what it is. Moving on.
Yes, sir.
Here is A, here is X, here is B, if I spent the time doing it to calculate the inverse of A, this is the inverse right here. Okay. Next step, I'm going to take this inverse and multiply both sides. So, well, that's not going to show anything, but here you go. Here's A inverse, and here's B. Let's look at that real quick. Row 1 times column 1. What is 15 times 10,000? 150,000. Okay. Second row times this column. Oh, I didn't finish. What am I doing? What am I doing? I'm not done yet. Okay. Negative 200 times 730. Negative 146,000. Okay. Negative 2 times 0. Okay. And just out of curiosity, what is 150,000 minus 146,000? Hopefully it's 4,000. Okay. So now let's do row 2, column 1. Negative 21.5 times 10,000.
Negative 215,000.
I think that's right.
That's what my calculator said.
300 times 730.
219,000. Yeah.
And does that give me 4,000?
Yes.
Okay. What about row 3 times my column?
750,000.
75,000 maybe,
Yes, I'm sorry.
minus,
Yeah, negative 73,000.
okay, 75,000 minus 73,000.
2,000.
Okay, so there it is. So by getting the inverse of A, multiplying it by my answers, I get this final answer where X is 4,000, Y is 4,000, Z is 2,000.
So we'll just couple.
Okay. Moving on. Okay. That was it.
I have to make this to calculate